In the setup for this module, it's going to be about wood framing. And this is preparation for the Construction Tech series that we're going to take. The first Construction Tech 1 will actually really deal with wood frame residential construction. And so part of this course is to help prepare you technically for making the drawings and starting to understand the basic concepts. So our project or our module is going to look like this. We're going to make a building wall section, put some windows in it and a roof, and then cut a section as we've done it in previous drawings, and then go in and label and add elements in order to create a complete story about how that wall is constructed. And we have to do that because our software really doesn't create all the complexities that go on inside the walls of our buildings. Revit particularly, and a lot of BIM modelers do not actually detail where the studs are going and the other elements. It's not to say that other software doesn't do that. As a matter of fact, if I click on this piece of this image, it'll take us out to a plugin for Revit that will allow you to add in this kind of structural framing detailing. We don't experiment with this in the course because it's not free. I can't find an educational version of it. And even if it was, it would probably be relatively complicated on a learning curve to use. Nonetheless, that software is available if you wanted to get into the details of that idea of framing. Another one, a piece of software that I mentioned, is Chief Architect. I mentioned this before early in the course. And this is a unique piece of software because it does offer, and I'll take you out to the website, it takes you to another level of detail specifically for people that are making, in this case, residential architecture. So it does very good with the actual creation of the actual framing components that build up the architecture. But for the mainstream BIM modeling that happens in architecture firms, architects don't get down to this level of detail. And for good reasons, we don't actually need to. Builders very well understand this, and many times they can offer better concepts for the ways to frame elements that we might be intending to design. But not to say we should have a very good understanding about the typical common techniques of framing, because we need to specify them in order to get building permits that meet code. So we have to put a lot of detail in our drawings as to how the walls are constructed, where structural elements go. And it's very hard for students to actually understand these concepts, especially in our software, because it really doesn't contain a lot of this information. I thought this was really a good graphic of kind of the basic kind of nomenclature and words, terms you might need to understand in order to understand at least the basic framing of an exterior wall. So we have a double top plate. So if you think about this wall, it's being made out of 2x6 lumber, 2 inch by 6 inches. 2x6s aren't really 2x6, they're 1.5 inches by 5.5 inches. That's the nominal dimension of it. But we refer to those as 2 foot 2x6 lumber. And we space them between 16 inches and or 24 inches on center. They're spaced apart by that. Today in most modern construction, they're 24 inches apart. When we come to an opening and we have to interrupt the joist or the stud, the center stud that's supporting the wall and then eventually the roof, we need to put in what's called a header. And a double header is a typical way to do that. That is 2 pieces of lumber that is of sufficient structural strength to support the load that's being placed on from the roof and carry it over to the sides of the window or the opening. And the way that header, that beam that goes across to your rest, it rests on another stud, which is called a jack stud. And the intention there is that that's a way to carry that load along that element. Now, a jack stud can be a single. If there's a lot of load, there could actually be 2 or 3 added to each side. And so we have the idea of a double header then, and then a window sill plate, the piece of lumber that goes beneath the window, and then the bottom plate, the final piece of 2x material that creates the composition of a wall. So that's just an introduction, and we have obviously a software problem, and I've tried to really actually illustrate this. We're going to bounce out to Revit here in just a minute. So what I have here are 3 kind of illustrations that I've created inside of Revit. The first one we have is how Revit would actually draw a wall system. So here we have drawn a wall, that goes all the way down to the foundation. We placed a floor on the inside of the building. We have a foundation wall and a footer. But inside of this wall, we can only detail the idea of it having a solid piece of wood in it almost. We can't get to the idea of it having other kinds of structure. And so in order to do that, we have to add those details in later. So I want to just jump out here for a second to our Revit software, because I have a live version of this. And this shows you the idea of the things that are missing. So here we have a detailed wall inside of Revit. We have, and actually this wall is flipped. So I'm going to select it and hit the space bar. It's facing in the wrong direction. And I'm going to move it back out. Sorry for the delay here. Move it out to the face of the framing. So if we zoom in here, we have a sheathing, a piece of plywood, a 2x4, and then this white is the inside drywall of the wall. And then we have our floor system. But if we were to insert a window in here, we'd have no information about the other kinds of structural elements that are going on. The idea of the header or the sill plate, or even the insertion of the insulation. So I'm going to jump back to this idea of the 3D view. And what I've actually done is I've done what we would never really do in our actual drawing. I've actually drawn those components in a model. So here we have stud. We still have our outside sheathing. We have our regular what are called floor joists coming along here to support our plywood floor. And everything that goes in this horizontal direction, I've made red. And I made red because they actually have, they're the things that Revit can't actually display because they really don't exist in the wall. So if we go back to that section view, now we have the idea of these red horizontal elements. So here is the bottom plate of the wall. If we come up to the top, there's two top plates. And here's the end view of that double header element that we discussed to support over a window. And so once again, we'll look at a 3D view of that. So here we have that insulation in the wall. We have our studs, all this complex kind of buildup, and we need a way to illustrate that in a section view. And then once again, now I've turned those off so that we can look in this reference view and we can see those as just outlines. So what we'll learn in the module is how to graphically represent these by putting little X's on them to indicate that those are the ends of those framing elements, and then to detail how our insulation will look when we've added it graphically, which is what this batting look is illustrated here. So let me go back now to our presentation and kind of finish things up for us. So once again, if we were to, I can't really zoom in here, I've inserted the windows in, but all of these little details, these two top little top plates, the header over the window, all of those things are graphically inserted into our illustration. They don't actually exist in the model space. So these are things that we have to go back and add in order to communicate accurately how this wall is constructed. So I hope that's a good start for, I guess, getting you in the mindset of doing these kind of section wall details, which will become a really important part of what you do as an architect to communicate it. I've got this one last link that if you click out, it'll take you to a wood construction reference material. I'm not sure they'll mention this in construction tech, but this is really a huge, rich document that details all kinds of ideas about the way wood framing systems come together and are constructed and detailed. Here's a idea of what would be wind loads on roofs, in this case wind loads and uplift loads, but you can see this idea about how we're creating these sections and labeling these components, and just tons of details that would show you how you would construct these. Many times in architecture school you won't be faced with these, but when you get out into practice and you're working with products, you need to illustrate how the building's going to go together. Many times you'd be required to be doing this research in these kind of drawings. And one last thing before we go, our in-class project is going to be the modification of a shipping container. I've introduced this because it's really popular for architects to be challenged by clients with the idea that I bought this really cheap shipping container. There's thousands of them available, things that are shipped from one country to another, And trade balance is one way. So there's it would be empty containers going back. Costs too much to ship empty containers, so many of them are stranded in the United States. They're offered up for sale cheaply, and people try to reconvert them into other things. And the challenge for us in using Revit is to understand how to modify these models, because we don't have the conventional tools of drawing walls and inserting windows. So we take a while in this project to kind of look at what if we're presented with this custom element, which I will provide you as a 3D model. What can I do to make manipulations to it in order to solve problems for our client, whether it be a pop-up store or a small vacation house or what's called an accessory dwelling unit. I will discuss more of that in class. It's a great chance for you to express and experiment, so I hope you'll enjoy it.